Hello, welcome to Anson Griffin's occasional series of MATLAB tutorials. Today we're going to be looking at principal component analysis, and we have the script here. And just to say, none of this is my work. I took this from the MathWorks site here. All the code is taken from there, just to be absolutely clear about that. And the only reason I'm putting it up on YouTube is that some people may look at YouTube first rather than that. So really, I'm just going to run it, just to comment on it. But really, all the stuff is there, and as I say, none of the code is my own. One other thing, I'm not going to be dealing that much with the background. If you want to look at how principal components work, the maths behind it, where we're highlighted there, would be fairly decent. I find with my students that gives a fairly decent background to what's going on. And then in this particular one is all about detecting faces, and there's this link here, and that's where another lecturer gave this as a project to his students to do that. Today what we're going to do is we're going to be looking at PCA, as I said before, and we're going to have a training set and a database here. So let's just look at what's going on here. So what we have here is these are test images here, and here where the mouse is our training set. So when this runs, we're going to select an image from this one here. We're going to get the principal components of it, and then you'll get the eigenvalues, and then we're going to look at the database here. And so we have the 20 images, we have the eigenvalues of the 20 here, and we get the eigenvalues of this one here, and then we get the nearest match, and that gives it to us here. So just say what this chap did on the MathWorks site. He gave us these images, and these are obviously taken very closely together, but they are slightly different. They're not the same images, because if I look at this chap here, the properties of this lad is 6525 bytes, and if we look at the two images here, here is the first one. It's 6507, and the one beside it is, here we go, just one second, is 6506. So the images are slightly different. So it's going to get the eigenvalues of these. We then suggest an image of 1 to 10. It's going to get the eigenvalues of whatever image I put in from 1 to 10, compare them with the 20 here, and give us the nearest match, and that gives us an idea of what's going on. So just go back to the script. There we are. So that's what we're trying to do. That's from line 13 on. Just to mention one of the other things, you can use PCA as a means of compression rather than store the whole image. You just store the principal components or the eigenvalues of the image. So obviously that will have a much smaller file size than the actual image itself. And if you have the latest version of Gonzalez, Woods and Eden's book, he gives an example of characters that are rotated, and using the principal component analysis you can get them to be near vertical. Okay, just as an example of what to do. Okay, so let's run the script here. So we're asked here for the training database, there's the training database, so that's that. Now it's calculating the principal components of that, so we just wait a sec. It's now asking me for the test data path. So that's that one there. I go out to the prompt here, and it asks me for an image. So let's select chapter number 4. It tells me that's image 7, so is that right? There's the 4, and there's the 20, and anyway it's 7 or 8, and we get the best match there. So that's it. Very brief introduction to principal component analysis, and thanks very much for listening.